where is the ethanol? Ethanol sources have to be found. That's what the eminent speakers both said. We have certain answers, certain things which is going to come up. Let us first understand the Brazilian experience of Great Ethanol Program. We have Jaime Finguerut, who is a chemical engineer in postgraduate studies at the University of Sao Paulo Polytechnic School. He has been in the Brazilian sugarcane industry for 40 years. Since 2005, he has been working as a strategic development of the sector as a whole, looking for new technologies and new talents, new partnerships and new business models. Retired from CTC in 2017, created ITC, Institute of Technology for Sugarcane, with the objective of seeking enabling use of new technologies and new policies such as Renewable Bio in full-scale production, the big area of bioeconomy, biomass, bioenergy. Let's hear and see his presentation on Brazilian experience. Welcome, sir.
Feeling good. So we have lots of information to give to you. First, I would like especially to thank Dr. Patil. I believe he is one of the responsible for me to stay here. I came from the other side of the world, and I'm very happy to speak to you. Well, I've been introduced by Dr. Val. You see there in the bottom my email and my cell phone. I am sure that you are going to have much more questions than answers. So please send me your question. I will be happy to reply. Let me see. Okay. Here you have again my contact information. Let's start. You are not seeing so much here, but you saw that since 2005, I've been working on the strategy of ethanol production, the strategy of sugarcane production. And I've been tracing this system that is done every year by the World Economic Forum. You can see in the vertical axis the risks that we are facing. On the horizontal axis, the probability, likelihood to happen, and the damage that if these risks happen, what can do. You see that it is the first time that most of the most important CEOs and politicians and policymakers in the world, they can see the most important risks related to the environmental aspects and the situation that we created for ourselves. We are facing kind of a Frankenstein syndrome. You see? We are afraid of the monsters we created. You see, extreme weather, impact, climate action failure. We are, in most of the presentation here, you are speaking exactly about this. What to do? We have to change the situation. We are putting CO2 in the atmosphere, and we are facing extreme weather every day. In my country, most of the big cities, the capital cities, here, this time during the summer, we are full of water. people is losing their homes, and this is more serious every year. So, climate action failure, natural disasters, biodiversity losses. I've been talking to Geoff from Australia. Is he here? Dr. Kent? You see the bushfires that they are facing there in Australia. I was speaking to him, and he said, well, if Australia stopped using fossil fuels, let's say this would reduce 2-3% of the emissions in the world. Are the bushfires to stop because of this? Most likely not. So, my point beginning this presentation with these facts, is that I am convinced after 41 years working with sugarcane that we are part of the solution. For example, one of the more serious, let me see if I find here. I will skip most of this, I'm sorry. See, you have here most of the most important research articles about this topic. The big balls you can see are the impacts that we have. One of these most important scientific articles dealing with the how to solve the situation we created propose that we plant billions of trees. In all places that we don't have agriculture and we don't have cities, they propose we plant trees. In my perspective, I believe that sugarcane is much more efficient taking out CO2 from the atmosphere and creating prosperity than just planting trees. You see, in the morning we had some agriculture presentations, and yesterday as well. One of the presenters, he showed that sugarcane is the most productive crop we have today, much more than eucalyptus or any other things. That means that we have a problem. It's a very serious problem. You see that the risks are interconnected. And if one of these risks happen to happen, if we can see, for example, human-made environmental disaster happening worse than we have today, there will be a chain of disasters. You see? This is the interconnection of Amazon rainforest, Arctic sea ice, Atlantic circulation, boreal forest, coral reefs. All these you've been hearing as problems. And they are interconnected, one pushing the other. So, my presentation today is to convince you that sugarcane in an integrated biorefinery, and this I agree totally with Ramakrishna, replacing all fossil, and in this aspect we are much better than solar energy because we are fixing carbon, creating bioenergy, but fixing carbon. This is the big difference. Okay, let's move. This is just part of the news that you know that are happening. And now let's move to sugarcane belt. Okay. And these are the most important sugar countries in the world. You know, Brazil and India are the leadership on this point. So it's our responsibility to show the world that we can go much further with sugarcane. There is some problems with the format, but anyway, what we are seeing here is that Brazil and China are the most important sugarcane country, and third, China and Thailand and Pakistan and Mexico, etc. These are the possible countries where we can grow a lot the production of sugarcane, fixing carbon from the atmosphere. These are the places where we have sugarcane. In my presentation in the first day, perhaps you saw that we have, in all these points in green, we have the right temperature, the right humidity, the right rain for sugarcane, and that's why sugarcane evolved in these places. But we can, like it was called in my previous colleague, we can go for more productive sugarcane, for example, energy cane, then you can expand the geography of sugarcane a lot. These are the places where sugarcane is in expansion. Of course, Brazil and India are there, but we have several other countries going for sugarcane and growing much faster than we are here. In terms of productivity, actually Brazil and Australia are not that good. We have Colombia, Swaziland, Guatemala, Malawi as leaders in productivity and also in sugar production per hectare. But in our case, our countries, we are producing millions, hundreds of millions of tons of sugarcane. We have there places very geographically defined. For example, Colombia, only in the Valle del Cauca, but in Brazil we have 25 different climates and soils for growing, and so scale made the things less optimum, but much more resistant and flexible. This is about productivity. I will skip this. These are the most important countries in biofuels, considering ethanol and biodiesel. We have Brazil, Indonesia, Germany, China and India are very important as well. I have some figures about India, but you know already, and people discussed this point already. This is your slide. And just to show the situation in India, this is the situation in the world. You see that ethanol in the world is quite stagnant for, let's say, the last 5 years. We are around 100 billion liters per year, and it's not changing that much, okay? But the technology is there. Brazil, including, is going for corn ethanol, but using biomass as a fuel. So we can, and we are going to see, Oliveira showed us the potential for RenovaBio almost to double the production, and so we are going to see in the next few years this trend to go up, and I hope in most of the sugarcane countries in the world they will increase a lot the production. Actually also, you see, because people now realize that carbon is perhaps the most important product, not exactly sugar and ethanol, but carbon, because the carbon that I do not emit, or the carbon that I put on the soil, affects the whole planet. You see? And now it is something that can bring revenue. I believe that the value of carbon will grow exponentially. In the first, I participate in the renewable building. In the very beginning, the models, they put a value on carbon for $10 a ton only. In every place where we have a carbon market, it is $30 and can go for 100. And so this is going to be a strong driver for increasing ethanol production in all these countries that I mentioned, because they know how to make. It's just a matter of increasing production. Okay, this you know very well. Sugarcane is the most important raw material. Grains, especially corn, also is very important. Molasses, corn and wheat molasses, and then sugar beets, just a little, and cassava, mostly in Thailand. All this can be optimized and work together, making a flexible production, making the production for the whole year, using the residue of the other, like Dr. Yadav, I don't know exactly how to say your name, Yadav, increasing CO2 efficiency, increasing output of the distilleries, increasing sustainability, increasing feasibility. That is what we need. We don't need so much support, subsidies. We need demand. We need investment. Okay, I believe this is the most important graph in my presentation. I will move to this big arrow of CO2 going down is what we have to do. Do you understand? The amount of carbon in the agricultural soil in the whole world is much bigger than the amount of CO2 in the atmosphere. The soil we have, the soil that we live on, is the main sink for carbon. And everything that we do with sugarcane, we have to sink, putting back CO2. Of course, we are doing this. For example, not burning the leaves. We are increasing organic soil in the sugarcane fields, increasing fertility, increasing water, increasing physical properties of the soil. But we can go much further. We have all the residues from the mill itself. We have the excess straw, excess bagasse that we can put back. And making this CO2 balance, we are going to see that sugarcane can be highly negative in emissions. You see, some scientists, they make calculations that just increasing 0.4% of carbon in the soil per year is enough for burying all our emissions. Do you understand? We have the solution. For example, the soils we use in Brazil are very poor on carbon. That means that you can grow from 0.2% carbon to 2%. multiply by 10 in 10 years. That means that we can eliminate all our emissions in sugarcane. That's amazing. Of course, it's not easy, but there are technologies. For example, pumping back vinasse after biodigestion. The carbon is going to be stable, and this carbon will stay in the soil. For example, producing biochar or biochar from bagasse, from straw. It is stable and can stay there, and increasing sugarcane productivity in a positive cycle. Totally, as much sugarcane we do, more carbon we put on the soil. Okay, I will make the animation again. We have landed sun, we plant sugarcane, we have a cycle in Brazil of at least 4 cuts growing again sugarcane. The harvest of sugarcane will move to the mill. The mill will produce the byproducts, vinasse and filter cake. These are going to return to the soil, increasing this green arrow of CO2 back there, and also saving on nitrogen and many other emissions. This means an agro-industrial refinery, not only a biorefinery far from the soil. We have to be connected to the soil. That's my main message. Okay? We are going to the end. In Brazil, you know, we have 411 mills that are in operation. We are saving 535 million tons of CO2. That is pretty amazing. Okay, you see that today we know how to make 150 tons per hectare. We know these are true data. But again, this is for a special sugarcane producer that take care of its production. In Brazil, because we have 8 million hectares, this cannot be done economically. But the potential for sugarcane is here. Sorry, too much information, too little time. I will skip most of it. Okay, I am not seeing the picture, but sugarcane can reach 320 tons per hectare per year in a special conditions. I mean, we now have the tools for assessing sugarcane genome. We have the CRISPR technology that is not considered to be genetic modified technique. We have the microbiome tools. Recently, perhaps you didn't hear, but researchers in University of Campinas, he made a transplant of the microbiome of the sugarcane to corn. And this experimental corn with the sugarcane microbiome could produce twice as much corn. So all these tools will make us much closer to the, let's say, 50% of the maximum theoretical potential. Finish. Thank you. Let me just put the last one here and finish. I'm sorry, I speak too much. Here. You see? These are true pictures, and this is a normal guy over there. The size of this. These are the transgenic sugarcane that CTC is producing for BT. And I will put the last one like this. You see that I have to put my glasses. Like Dr. Yadav mentioned, you cannot see exactly, but the CO2 efficiency of a typical Brazilian distillery, the carbon efficiency is 17%. You see this big black arrow? These are waste of carbon. We are wasting the carbon in the leaves. We are burning the bagasse and wasting the CO2. We have the CO2 from the fermentation. That means that we can multiply this by 5 in order to have a bigger carbon efficiency. Thank you very much. Yes, sir.
Giving opportunity for any questions because we are running out of time. There are 2 more presentations. I'm making separate. I have my one presentation here. So, next speaker is Tomsa Destil, Mr. Roman Rudkowskyj, is a deputy managing director of the company, former engineering manager of exploration of Colombo